Hello everyone, this is Mr. Mangieri, and today we're going to fill out our notes on lesson 7.3, graphing quadratics from Vertex form. As you're going to see pretty quickly, this lesson and 7.2, which is transformations of quadratic functions, are very similar. Now the reason that these lessons are separate to begin with is because when you're talking about transformations of a quadratic function, that's something that can basically be used with a lot of functions. So not only are those transformations useful for quadratics, they can also be used for cubic functions, absolute value functions, quartic functions, etc. When we're talking about graphing from a quadratic from vertex form, those transformations are useful, but they're useful because a quadratic itself has a specific vertex point. And if we understand what those transformations do to the vertex point, it makes graphing quadratics particularly easy. So before we talk about graphing from vertex form, I just want to go over the graph of the parent function itself, f of x equals x squared, so we can get a look at that pattern, because knowing that pattern really well is going to help us in this lesson. So just like any function where we're relating x to y, if we want to graph it, worst case scenario, if we don't know how to graph it, we can just plug in random points. So I have a table right here, and we're going to just start plugging in these points. So I'm going to start in the middle of the table at 0. So if I plug in 0 to x squared, 0 squared is 0. Okay, so I have a coordinate at 0, 0. So I have that point right there. Then if I plug in 1, 1 squared is 1. So that means I have a coordinate over 1, up 1. And let's see what happens when we plug in negative 1. When we square a negative squared becomes a positive. So negative 1 squared is also 1. So that means when I move forward 1, I go up 1. But when I move backwards 1, I also move up 1. Okay, now let's look at 2. So we plug 2 in. 2 squared is 4. So that means at 2, I'm going to go up 4. So I have a coordinate there, 2, 4. And let's look at negative 2. Again, negative squared is going to give me a positive. So negative 2 times negative 2 is positive 4. So not only am I at y value of 4 for x equals 2, but I'm at a y value of 4 for x equals negative 2. So I have coordinate negative 2, 4, 2, 4. At this point, you should see a pattern. So when I figure out, when I plug 3 in, I get, 3 squared is 9. You should realize that negative 3 should also be 9. So I have a coordinate at 3, 9. And negative 3, 9. And that gives me my parent quadratic function, right? So it's important to note here that my pattern from my vertex is that I'm going to move over 1 and up 1 in both directions. And when I move over 2, I move up 4 in both directions. When I move over 3, I move up 9 in both directions. So like I said, that pattern itself is going to come in handy for this lesson. So let's just fill out these key characteristics as a review from the first lesson, 9.1. So here we have a vertex at 0, 0. That's my minimum because it's a positive quadratic. Since my vertex is 0, 0, the axis of symmetry is going to be x equals 0. Domain of all quadratic functions is all real numbers. The range, in this case, my lowest y value is the vertex 0. So I'm going to start at 0, and I'm going to go to infinity, right? As x approaches infinity, so as x moves to the right, the y values are going up, right? So that's going to be infinity. And we know because it's a quadratic function, it's symmetrical. So if as x approaches infinity, y approaches infinity. If x approaches negative infinity, so if it goes the other way, it's also going to approach infinity. In this case, I have only one x-intercept, 0, 0. And I have my y-intercept is actually the same, 0, 0. My increasing interval is from 0 to infinity. So from my x value 0 to infinity, my graph is going up. From negative infinity until 0, my graph is going down, so that's my decreasing interval. Now for some theoretical problems. So the first question says, if my graph was instead y equals 2x squared, let's see what happens. So basically what this means is I'm going to plug in my x value, like I did in this table, right? But after I plug my x value into x squared, I'm going to now multiply it by 2. So 0, 0, what's 0 times 2? That's still 0, so that point's going to remain in the same spot. But when I go to 1, 1, when I plug 1 in, 1 squared is 1, but then 1 times 2 is now 2, which means on the other side it's also going to be 2, right? Because we have this parabola is symmetrical. What about 2, 4? So if I take coordinates 2, 4, I plug 2 in, 2 squared is 4. 4 times 2 is now going to bring me all the way up to 8. So that means at negative 2, I'm also going to be at 8. So if you notice, and again, this should be kind of review from the last lesson, our graph gets skinnier because it's vertically stretched. So every time I plug in, a value for x squared, I'm not only just plugging in x squared, I'm also multiplying by 2. So instead of going over 1 up 1, now I'm going over 1 up 2. And instead of going over 2 up 4, I'm now going over 2 up 8. Because again, my ratio that I'm multiplying my quadratic by is 2. So I'm going to take my entire pattern and I'm going to multiply it by 2. What if instead I had f of x equals negative 2x squared? So in this scenario, now I'm taking all my coordinates. So again, I'm plugging in, let's say we use 0 first. I plug in 0, I get 0 squared is 0. Now multiplying by negative 2, 0 times anything is still negative, right? 1, I plug in 1, I get 1 squared is 1. 1 times 2 is 2, but now it's negative 2. So now it's, instead of going over 1 up 2, I'm now going down 2. So I'm going to do that on the other side. And since in y equals 2x squared, when I plugged in 2, I got 8. If it's negative 2x squared, now I'm going to go over 2, down 8. And again, symmetrical, so it's going to go on the other side as well. So that little negative in the front didn't change how much the graph was stretched, but it did change which direction the graph was going. Okay? So hopefully that explanation of, the 2 and the negative 2, how they affected x squared actually serves as some pretty good representation of how a is going to change our quadratic graph. Let's talk about h and k really quick, because last lesson you learned that the h represented a horizontal shift of your graph, and the k represented a vertical shift in your graph. Well, if our parent function always has a vertex of 0, 0 for our quadratic, and the h represents a horizontal shift and the k represents a vertical shift, if, let's say, instead of y equals x squared, I had y equals x minus 5 squared plus 3, if I just take this vertex point and move it along these transformations of positive 5, right, because it's in the parentheses, so it's going to be the opposite, and so I'm moving over 5 to the right, up 3. If I just take 0, 0 and move it along that transformation, I'm going to get to the point 5, 3. And as you can see, the vertex actually became the transformations, which is why we particularly like vertex form for quadratics, because the reason it's called vertex form is because HK literally is the vertex. So when we have a quadratic in vertex form, that's going to make our lives so easy, because as soon as we look at the function, as soon as we see the h and the k value, we should know what the vertex is. Now, as we were saying in the last slide, a represents the vertical stretch or compression. This will affect the pattern of the quadratic curve. So, like you saw in the last slide, as soon as I added a 2 in front of that x squared, instead of going over 1 up 1, I'm now going over 1 up 2, because basically I take my entire pattern and I multiply the y value by whatever that a value is. Also, as you saw in the last slide, if there was a negative in the front, then the graph will reflect over the x-axis, and open downward. So as I like to say in class, this is like a lot of words coming at you. The best way to really handle this, like most things in algebra, is to look at some examples. So let's take a look at a couple examples of this. Okay, so first example here, the question says graph the quadratic function by placing the vertex and follow the pattern of the quadratic, the parent quadratic, adjusting for the a term when needed. So let's look at this quadratic we have here. It's y equals x plus 4 quantity squared minus 2. So as we were saying, based on the last lesson you guys did, you know that this 4 is going to move you to the left 4, and this negative 2 is going to move you down 2. But if the vertex starts at 0, 0, that means 0, 0 is going to move to the left 4, down 2, meaning that the vertex is going to become negative 4, negative 2. Just like it shows right in the equation. So once you figure that out, that vertex is actually just the numbers that are described to you in the vertex form of the equation, it becomes very easy to start graphing your quadratic, because I know the vertex is at negative 4, so to the left 1, 2, 3, 4, down 2, that's my vertex point. Which means my axis of symmetry is at x equals negative 4. Remember, the axis of symmetry is always x equals whatever the x-coordinate of your vertex is. It also asks if this is a minimum or a maximum. Well, that's going to depend on our a value. Is our a value positive? Is there a positive or a negative in front of our x squared? It's a positive, so that means the vertex is a minimum because the whole graph is going to go up. Now, speaking of what's in front of my x squared, what's my a term here? A lot of people would say nothing, but that's not true. Remember, when there's nothing in front of x, that really means the a value is 1. If the a value is 1, it is not going to affect the pattern of our quadratic. Meaning, as soon as we find this vertex point, negative 4, negative 2, we just start at that vertex point, and we follow our pattern. So as we move to the left and the right, and to the right 1, so to the right 1, we're going to go up 1. To the left 1, we're going to go up 1. Our pattern also said when we move to the right 2, we go up 4. And backwards 2, we also go up 4. And if we move to the right 3, we're going to move up 9. Same thing to the right. You go to the right 3, you go up 9. And if you think about it, this is a quadratic function, it's x squared. You're really just thinking, as I move, in the x direction one number, I square that number to tell me how far to move in the y direction. And this is the function y equals x plus 4 squared minus 2. Domain, all real numbers, because it's a quadratic function. The range, my lowest y value is now at negative 2. So it's going to be from negative 2, and it's going up to infinity. So now to take a look at 2 more problems. These questions are a little more difficult because not only do we have a change in the vertex, but we also have a change in the a value. So let's see how that a value affects what's going on here. So if we look at our function again, based on the transformations you guys learned, that x plus 1 quantity squared tells me I'm going to move everything to the left 1, and that positive 5 is going to tell me to move everything up 5, which means the vertex starting at 0, 0 is going to move to the left 1, up 5. The vertex is going to become negative 1, 5, with an axis of symmetry of x equals negative 1. So let me graph that point. Negative 1, 5. Now, next we have to determine, is this a minimum or a maximum? Well, in this case, is there a negative in front of my x squared? Yeah, there is. There's a negative there, so this is going to actually be a maximum because the whole graph is negative, meaning that point's going to be the top point. Now, that also coincides with my a term. Remember, when there's nothing in front of x squared, there's really a 1 in front of it. Well, if there's a negative, that means it's negative 1, which means my entire pattern is now going to be negated. So instead of moving to the right 1, up 1, I'm going to move to the right 1, down 1. To the left 1, down 1. Same thing when I move to the right 2. Instead of going up 4, I'm now going to go down 4. Same thing to the left 2, I'm going to go down 4 as well. Over 3, I'm now going to go down 9. Same thing to the left 3, down 9. And there is the quadratic negative x plus 1 quantity squared plus 5. Domain, all real numbers, because we're looking at a quadratic. The range this time, I have a maximum, right? So this time I'm going to start at negative infinity and go all the way up to my maximum, which is my vertex at 5. Now let's take a look at question C. So in this question we have y equals 2x squared minus 3. So since I don't have anything in parentheses with my x being squared, that means my horizontal shift doesn't actually exist, which means my vertex is still going to have an x value of 0, but I do have a vertical shift down negative 3. So my vertex now moves to 0, negative 3. There's no negative in front of the x squared, so that means this is a minimum. My axis symmetry, x equals 0, because that's the x-coordinate of my vertex. My a term in this case, the a term in front of x squared is 2. So let's see how that's going to affect our pattern. So starting at my vertex, the pattern of a quadratic is usually I'm going to move over 1, up 1. But because my a term is 2 in this scenario, instead I'm going to move over 1, up 2. And also, again, axis of symmetry. Since I went over 1, up 2, I'm going to go backwards 1, up 2 as well. Typically, when I move over 2, I go up 4. But my a term, being 2, means instead of going over 2, up 4, I'm going to go over 2, up 8. Because everything is going to be multiplied by this a term of 2. So instead of going up 4, I went up 8. Same thing in the opposite direction. And then, theoretically, if I move over 3, I'm supposed to go up 9. Everything's multiplied by 2, so if I go over 3, I'm supposed to go up 18. I don't have enough space for that on my graph, so these 5 points will have to do. And there's my graph, y equals 2x squared minus 3. Domain, all real numbers, because it's a quadratic. The range, again, I have a minimum here, so negative 3 is my minimum y value, and it goes up to infinity. So here's one more practice problem. I would like for you guys to pause the video and actually try this one on your own. You want to graph f of x equals negative 1/2 x plus 3 quantity squared, and then identify the key characteristics like we did in the do now. Alright, so just pause the video, try this question on your own, try graphing it, figure out the vertex, determine how the a value is going to affect your pattern, and then I'll come back with the solution and explain how I got to that solution. Alright, here's our solution to the practice problem. F of x equals negative 1/2 x plus 3 squared. So let's talk about how I got here. If you look at the equation, the transformation we have is a horizontal shift left 3. And then there's nothing after the x squared, so there's no movement up or down, which tells me my vertex is at negative 3, 0, right there. And we also know that that's a max because the x squared has a negative being multiplied to it, so that tells me the whole graph is going to now go downward. We also know my axis symmetry is x equals negative 3, because that's the x-coordinate of my vertex. The domain is all real numbers, because it's a quadratic function. And because the vertex is a maximum, that means the range is going to be going from negative infinity to 0, the y-coordinate of my vertex. Let's talk about how I got the rest of these points on these quadratics. So I'm starting at negative 3, 0 as my vertex. Again, the pattern usually goes over 1 in both directions, up 1. Now, because my a value is negative 1/2, instead of going over 1, up 1, I'm now going to go over 1, down only 1/2, because again 1 times negative 1/2 is negative 1/2. So I'm going to do that in both directions. Then as I move over 2, typically I would go up 4, but 4 times negative 1/2 is negative 2, so instead of going over 2, up 4, I'm going to go over 2, down 2. The next coordinate, and I do that in both directions, the next coordinate over 3, I would typically go up 9. 9 times negative 1/2 is negative 4.5. So instead of going over 3 up 9, I'm going to go over 3 down 4.5. And I even went a step further and found these 2 points as well. X squared, if I were to go over 4, I should go up 16, but times negative 1/2, that's down 8. So I'm going down 8 instead in both directions as I move over 4. So that's what gave me my graph. So for the rest of this information, this is more stuff I can figure out from the graph I created. Because I have a maximum here, as x approaches infinity in both directions, the graph is going to be going down. So it's going to be going down to negative infinity in both directions. That's my end behavior. The x-intercept, as I can tell, is negative 3, 0. The y-intercept is 0, negative 4.5. And you might be wondering, like, how would you get that if you weren't graphing like if you didn't graph enough points to get to that point? Well, we already know this because we've talked about this all year. The y-intercept happens when x equals 0. So if you really wanted to, you could have just plugged in 0 for x. 0 plus 3 is 3. 3 squared is 9. 9 times negative 1/2 is negative 4.5. So that's my y-intercept. The increasing interval, the graph is increasing from negative infinity until I get to the x-coordinate negative 3. The graph is going up. My decreasing value starting at negative 3 and going to infinity, the graph is going down. Alright, so I hope this video was pretty informative. If I went too fast at any point, it is a video, so you can always pause it, rewind, slow down. Also make sure to write down any questions you have for our next Google Meet session so you can ask about what you had questions on for this. Like I said at the beginning of the video, this topic is pretty similar to the last topic, so I think most of you guys will probably figure this out pretty quickly. So just make sure to finish any practice I assigned to you on Google Classroom and have a good rest of your day.